Hello. Now let's talk about axial stress. This one is, it could be tension or compression. Then after that, let's talk about shear stress. Then bearing stress. All of them, the formula is stress force over area. Now the difference between the three is the area. For the axial stress, the area is perpendicular. Area is perpendicular. For the axial stress, perpendicular. For the shear stress, it's parallel. For the bearing stress, this one is the pressure or napipitpit in Tagalog. Now let's demonstrate. I will demonstrate it to you. For example, I have here a paper, then so that is a shear stress. That is an axial stress. Okay, the area, if I explode that one, that's the paper, the area that I'm dealing is this one. So if I cut it, so this will be the area. Okay, perpendicular to the axis. So again, the thickness and the length. So that is the area. So take note of that. Okay. Now, another one, let's see this one. Okay. This is bigger or thick, has a greater length. Then, what do you think is the failure, the location of failure? So I reinforce this one so that it will not shear. So let's see. Okay. So it will not break here because the area is lesser here. Okay, this one. So again, it's also a tension, axial load, but it breaks in the smaller area. Why? Because the stress is greater here, because the area is smaller. Or the area, so the area would be this one. Now again, the area is important. Okay, you will have a wrong computation if you don't get the correct area. So the area is this. It doesn't include the whole. So only this one. Okay, so that is the area. Again, the whole is not included. So like that. Okay, so that's only the area. Now if I draw it, it will be, if you're looking at this one, it will be like this. So this is only the area. Don't include the whole. So again, compared to last time, this is the area here. So it is more stress. This piece experiences more tensile stress in the lesser area. So take note of that. Now let's go to shear. Now in terms of shear, I will demonstrate. So again, here, okay, I'll put a force like that. So it's sheared. So the failure is not here, but in here. Okay, that's what we call a shear. But again, let's simplify it in strand of materials. So the shear, the area would be this one. So I hope I will have a good piece. Okay. Oh, it's broken. So I hope you can imagine the area is the sheared or the napunit. It should be like this. Okay, but I will just show here. So the area is here, this one, okay, until the here at the middle of the diameter. So that is the length until here. So there, okay, of course this one and the other one is here. So that is the sheared area. Okay, so I hope you understand. Again, that is the sheared area, this one and this. So that is important. So for shear stress, that would be, if this is the hole like that, okay, oops, sorry, the sheared area is this one and this. Okay, so I hope you visualize it. So this one, okay, so that is important. Okay, so that is the shear. It means napupunit. Okay, now how about the bearing? The bearing stress will happen, let me see, where's the other, oh, I don't have the other one. Anyway, the bearing stress is, ito yung in Tagalog na pipitpit. Okay, I will just put it like that. If you notice, there is a deformation here. Okay, there is a deformation here. Okay, yan yung napipitpit, nape-pressure. So, if I draw it, okay, like that, this one, this is the napipitpit. Okay, but for the area of bearing, bearing stress, okay, for the area, this is one is the projected. If I look at this one, the projected is, okay, wait, where's the other one? Okay, here. The projected is this one. Okay, projected, meaning, if I look at the hole, this one, if I look at this one, it will become like that. Okay, yan. If I look at here, become like that. So this is the diameter, and this is the thickness. So I hope you understand it all about the area. And of course, the force is the same in the same system. Now, the failure will depend on the weakest material or in the area. Okay? If you have a uniform area, and as shown earlier, in this case, the weakest is the shear. But if we have a hole at the middle, okay, it could be the weakest is the bearing. Okay? Or if that is reinforced, maybe the weakest is this one, tension. So you have to know, you have to compute them all, so that in the machine design, you will consider them. Okay? So ganun lang naman ang axial, shear, and bearing. Now, we are concerned of this piece. It could be, if this is stronger compared to this one, this would shear. Meaning, dito naman mapuputol. Okay? Pag naputol yan, ito yung area niya. Okay? Meron din siyang bearing. Yung area niya, ito naman. Yung napipitpit. Okay? Tension, wala dito except kung ginanon mo. Okay, again, which is yung concern mo, ano yung weakest part, kasi yun yung i-design mo. In machine design, I would prepare na mas stronger itong piece na to compared dito. Why? Because I could easily replace a bolt compared to this piece. Because this piece, of course, this is cardboard, but if this is metal or aluminum or something, I will don't want it to break because this is easily replaceable. This one hindi. Imamachine mo pa. O depende sa parts, pero look for the design, yung weakest link, yung madaling i-replace. Okay? I hope you understand axial, shearing, and bearing stress.